Hello, good afternoon. Thanks very much for coming, especially with so many tracks in parallel, so interesting, so it really means a lot. I'm Diego, and I'm going to make a demonstration of Conan. If you expected this, I'm sorry, I'm not taking off my t-shirt. So actually, I'm going to make a demo about Conan Package Manager. Okay, it is a free and open source MIT license for managing C and C++ packages. As I told you, it's going to be a demo. I have many slides here, but I'm not going to use them. I will share with you, so you will have to review things and ask questions, but I'm going to do it live. So I'm going to start with an example. Here I have a folder with 3 files. The first one is the source file that has some includes to Poco library, also to Boost. I'm going to use Poco threads, and I'm going to use Boost regex. As you can see in the main function, I'm using both the Poco threads and I'm using the Boost regex to do different things. So here is my source code, very simple. What do I need with Conan? I'm going to write a Conan file. A Conan file has 3 sections in this case. First, I declare my dependencies. They are going to be Boost and they're going to be Poco. Then I'm going to say that I want to build it with CMake. So in the generator sections, I define CMake, and you'll see a file that is going to generate. And then I also can define some options. In this case, I want to use both Boost and Poco as static libraries. This is all I need. I'm going to move to the build folder. It's just a temporary folder I can move. So I'm going to just make sure everything is clear. And I'm going to issue an install command over the Conan file. Really fast. Of course, I'm cheating. The packages are already cached in my machine. I didn't want to trust the Wi-Fi. The Wi-Fi here is very unreliable, so they are cached. But otherwise, you will have a download for a few minutes to download the packages. Okay, so that's all. As you can see, I have 4 packages there: Boost, Poco, and also OpenSSL and setlib, because Boost and Poco depends transitively on them. Okay, I can, in fact, inspect my full dependency tree. I can issue a Conan info command, and I will check that my project requires Poco and Boost, and then Boost is required by the project and requires in turn setlib, so I can navigate the full dependency tree upstream and downstream. And I also get some basic meta information like the remote. For example, I can see that the place I got the Boost packages was from the Conan.io server. I could get it from other servers too. So as you can see, also I have the setlib package here that is required by both by OpenSSL and by Boost package. Okay. So the Conan install command has generated 2 files for me. I'm going to spec just the CMake one. It is very large, but it is very simple. It has just a set of variables, CMake variables, that define the typical things. For example, defines the folder in which the Boost package lives. It defines the include folder for Boost, the library folder for Boost. It will define the libraries for Boost, all the names for the libraries. And it will also declare, for example, here we can see that it's declaring some defines. For example, I said to use the static library. It is defining Boost uses static libs, because the consumer of the project needs to use this define to actually link with the static Boost. This file will be the same for the Poco library, the setlib library, the OpenSSL library, defining many variables. I can use these variables as is, but I also have some macros. So those macros here are just utility macros. I will show you how can we use it. So now I want to build my project. I'm going to show you the main CMake list for building the project. It is a typical CMake with my targets. In this case, I'm building just an executable. And I'm introducing just 4 lines, including the file I've just showed you with the variables. Okay? If I want to set up everything automatically, I can use the Conan basic setup macro, and it will do everything for me. Otherwise, I can just use the variables and define the include directories and everything like I want. Okay? I could also define my CMake targets if I want to. Most is absolutely transparent for the user because, for example, the find boost still works. So I can use the variables obtained with the find package about boost. So the rest of my CMake file will be exactly the same using regular boost installed by my means in the machine or using Conan. You can switch them just by if the Conan build info CMake file exists or it doesn't exist. So I'm going to show you, I'm going to Studio 14, 64 bytes. So I'm configuring my project right now. It's a bit slow because in Windows CMake is a bit slow for configuring projects. And now I'm going to build my application. Now I can run it. Very simple. So to be clear, I'm in Windows. This is a Windows machine. And I've installed Boost, Poco, OpenSSL, and Self-lib, and this is in my project. This is it, OK? So what happens? You have seen that I'm using the Windows 64 architecture. What happens if now I want to use a 32-bit architecture? So I'm going to install the binaries. Let's remove everything just in case. Install. So now I'm going to define an architecture for 32 bits. So I get now different binaries. The process will be the same. I just have to define that I'm not using the 64 architecture anymore for CMake. And I can build again my application. Now this executable is a 32-bit executable, and it's linking against Boost, Poco, OpenSSL, and Setlib built with 32-bit architecture too. We can inspect what we have in our local cache, in our computer. There are some packages there. I can actually check, for example, the details for this one. So if I do a Conan search for this package, I can see that I have 2 binaries for this package. One is using the 32-bit architecture, and the other one is using the 64-bit architecture. Okay? Every package, you can see that it has an ID. This ID is a hash. It's a SHA-1 hash of all the settings and all the options of the package. So if you change the settings and you use a different compiler version, it will generate a different binary. If you change the option and you're using the dynamic library, it will have a different hash, so it will generate a different binary too. So in this way, you can have so many binaries as long as any number you want to build in your system. Okay. So what happens if I'm not a CMake user? Question over there?
So you said you have different binaries for different compilers. So for example, there are 3 updates in Visual Studio 14.
The updates are not supposed to break IBI compatibility. So actually, the settings has to be defined that they change and the hash is different when the ABI is incompatible. Otherwise, it should generate the same hash and the same binary for compatible settings. I can always, and now I'm using binaries. If at some point I want just to build from sources, I can specify build from sources everything. I can specify build from sources Boost in this case, for example. I'm not going to do it because it can take a while, as you know. But what happens if I don't want to use CMake in my project? I'm using just Visual Studio. Okay, so let's change the Conan file, and now I'm going to use a visual. Vim. Actually, I'm defining two generators. I'm defining a Visual Studio generator and a you complete me for Vim generator. Let's save the file. And run Conan install again. Okay, now I have two files. No, sorry, I have one visible file. Here is the props, the property files. This is a property file for Visual Studio. I can open my IDE, I can import this file, and this file will have all the definitions for linking with Boost, with Poco, and everything. So I can directly work with Visual Studio. No CMake at all necessary. And also we can expect that it is hidden. That's the reason. It has generated also a file for Vim, you complete me. So if you are working with Vim, it will load this file and you will get auto-completion for Boost and all the libraries you depend on. So this is more or less the way I use a package or use a set of packages, okay? How is the perspective for building packages? Okay, so if we want to create a package, we need a Conan file, a Python file. Yeah, over there. Sorry, I didn't get it.
The py file, the Python file that you showed was generated by Conan?
Yeah, the Python file for You Complete Me, it was generated by Conan. Yeah, Conan has many generators for CMake, for CMake, for GCC, for You Complete Me, and you can create new generators. Generators just install things, and with all the information it has from the include directories, the libraries, and everything, it can do whatever you want. It can generate a file with your configuration, with your build script, so it can match any build system you want.
If I want to write generator for my build system, is there an API provided that I can do that?
Yeah, the system Conan has an API that you can access all that information and generate that file. So writing a new generator for a new build system can take maybe one afternoon. So I'm going to show you, now I'm going to create a package for a simple hello library. Yeah. So I'm going to show you what I need. I need this is a recipe. This is a recipe to build the package. It is a Python script. Okay. First, I have the meta information for the package. I have the name, I have the version, I have the license, for example, and then I have two things. I have the settings and the options. The settings are defined by the user. Okay, so the user will define that he's using Visual Studio, such version, whatever. The options is something that can be defaulted by the package. In this case, this package is defaulting to build a static library. This can be changed, but it can say that it's going to build a static library by default. Okay. Now we have two ways to get the sources. Okay. The first one is the one I use most and the one I like is to get the sources from elsewhere. You will use the source method. And in the source method, you will have a git clone, you will have a download from SourceForge or whatever, and you will get the sources from somewhere else. I didn't want to use it now because the interconnection. So I'm using the other approach. The other approach is using the internal code. So I'm here declaring exports equal and a source folder. This is what it's doing is getting the source code from the folder and doing a snapshot. And it's capturing the source code and storing the source code in the package recipe. So the package recipe is totally full contained. When it has to build the binaries, it will get the sources from itself. It doesn't have to fetch the sources from elsewhere. Okay? So are two different approaches. And then the rest of the recipe is quite straightforward. You can use any build system you want. For example, the OpenSSL package we saw, it is built in Windows with Perl. Okay? So it is not necessary to use CMake. In this case, this package, this library, is using CMake, so I'm going to use CMake, and I define my project, and I define my build. And then I got my artifacts. Then I have the package method. The package method just extracts the artifacts, in this case the header libraries, the header files, and the libraries, the static libraries or dynamic libraries, for example. It extracts those artifacts and put them in a package folder, what is the package binary itself. And finally, I have a package information method. This method is similar to the PC files in Linux. It declares for the end consumer some things. For example, in this case, it is defined that my library is called hello. Why? Because in this way, the end consumer doesn't have to figure out the name of the library. For example, it's typical in Windows to add the D suffix to the library. So here, the package creator can say, okay, so if I am in debug, the name of the library will be this one. So the end consumer doesn't have to figure out. It will get just the names by default. So this is the recipe I need. The first step, this is in my user space. So if I want to use it as a package, I have to export, I have to put it in my local cache. This is done with the export command, with my username and a channel. Okay, so now it is in the local cache. You can see it is here. It is a package, and I can use it. I can use it exactly the same as I use the Boost and Poco. Everything in my machine, no need to upload anywhere the package. I can test, develop, and create packages in my machine absolutely offline. If I search for the binaries, there is still no binaries for this package, okay? So how can I test if my recipe is fine? It is right, it is working. So if I want to test it, the way would be to create a project, like the Boost project, use a Conan file, required, and just try it, okay? Instead of having this in a separate project, there is an utility, it's called the test package. So in the test package, you can embed such a test, such a project consuming the recipe in the same recipe itself. So we have the test package here with basically features, a source file with an application that is using the package I want to test. And it also contains a Conan file. This Conan file is not a package. It doesn't have a name. It doesn't have a version. It just has the build instructions, how to build my test application, and especially it has a test function. This test function will launch the application to actually test that it is working. And it has linked properly and it's working properly. Yeah. So the test package is nothing but a wrapper around Conan export, Conan install, create the project, build the project, and test it. Everything together. This is really useful for continuous integration. So for example, when we want to create hundreds of packages for Boost, we just upload this recipe to GitHub. Travis and Abbeyor will fetch it, and we'll launch test packages for many configurations. It's very easy. You can see here, it first got the package, build the package, then build the example project, linking with the package, and then execute the example project. And this is the result of the example project itself. Now I can check that I have a binary for this package because it has been built. And I can repeat, for example, for 32 bits. And it's going to do exactly the same. It will now create the binary for the package for 32 bits. It will run my test application, it will build my test application with 32 bits, links with the package, and execute the test again. And now I can see I have two packages, okay? So all of this was absolutely local in my machine. Now I want to share my recipes, and I want to share my binaries with the rest of the team or with the rest of the world. The first thing we have to know is that Conan is decentralized. It's exactly the same as Git, okay? So it includes also in the MIT project a Conan server. A Conan server you can run in your network behind the firewall on premises. It's as easy as just launching a server. Now I'm running a remote. It is in my machine, but it could be elsewhere. Okay, so as I said, it's git-like style. So I can list my remotes for Conan. Now I had just one remote. It's the Conan.io, is the way I'm getting the most packages, but I'm going to add a remote. I'm going to call it local, and it's going to point to my local host. Okay. Now I have two remotes. I could upload my hello package right now, but I'm trying to do something more interesting to show the real utility for this. I'm going back to my previous project, the Boost one. You remember? Here, setlib got from the Conan.io server. Okay, I'm going to upload this package to my local remote. So what I'm going to do is Conan upload the package to my local remote I've just added, and I'm going to specify that I want to upload everything. I could upload just the recipe, so the binaries will have to be built from sources from the consumers, or I can upload everything. I can upload the binaries. If the binaries match the requirements from our users, they will get the binaries, so they don't have to build from sources again. Yeah, uploading things. Perfect. As you can see, it has uploaded the recipe and it has uploaded two binaries. To show you that it is actually working, I'm going to remove setlib from my local cache. Yes, if I execute Conan search, now setlib is not in my local cache anymore, but I can search in my remote, and I will check that now setlib is in my remote. Okay, so at this point I could repeat. I could do the same for Boost, for PoCon, and for OpenSSL, and upload all those packages and binaries to my remote in my office. Okay, then I could remove the Conan.io, totally, absolutely. And if I want to get my packages again, I will just specify my remote. Now it is getting setlib from my remote. I don't need Conan.io anymore. This is totally safe. You can control your binaries. You can know that you are not getting binaries from the cloud or from whatever, and everything is under your control in your company. Here. Now setlib comes from my remote. Okay. So, time to finish. This is only a very small part of Conan. We have many things. Of course, we have the typical dependency management as conflict resolution, overriding dependencies for options. You can have dev dependencies for tests, for example. You can create packages for tools like CMake, for example, and you can install several versions of CMake and switch among them. There is a full tool for building packages on the cloud. It's called Conan Package Tools, and it integrates very well with Travis and AppBayer. It can even do things like generate things for Rust and for Golang. It can make packages for Go. So that's everything. So we're running out of time. So thanks very much. And if there is any question. Any question?
So it looks like you're using sort of old style CMake in there. Are there any facilities to consume actual CMake targets, or to even consume, like, in a mature CMake system that's already got its own install logic, pull out all the install targets and build those recipes?
Yeah. So the question if we are using like modern CMake features like targets, for example, the question is the answer is no, because we wanted to retain compatibility down to CMake 2.8. So what we did is to create just the variables. With those variables, if you can define create your targets, you can do it. Actually, there is an open feature request for having a generator that can create the targets. But so far, we prefer to have down compatibility to 2.8 than having the coolest features from CMake, because there's still too many people still are using CMake 2.8 or even 6. So at least we wanted to make sure that it works for everyone up to 2.8. Yeah. Any other question? Can you speak? Sorry, but I can hear you with the sound of the room. Maybe, is there a microphone? Maybe.
When you compile libraries, for example, for embedded development, you have to manipulate with compiler flags to.
We don't do cross-building. If you is the question. We have a full. The question if it's for embedded targets, we manipulate the flags or whatever. Yeah. So the answer is no. We don't do anything. I mean, everything is under the user control. So we have just those settings, like a hierarchy of settings, like the compiler, the standard library, different operating systems, different flags. And with those things, you can do whatever you want. So if you want to create your flags, modify your flags, you are responsible for doing that. So the package creator is the one who defines the flag. Conan is not doing, it's not automatic. It's not doing anything automatically. Okay. Thank you. I think we should finish. Yeah, the next talk. Yeah. So we're out of time. So thanks very much for everything. If you have any other questions, I will be here after the session. Okay. Thank you.